Hey guys, this is Chapter 11 test video. These are questions that could be straight from your test and also on your study guide. So here we go. Given R's, the radius of these cones, and the surface area of 245, what would be the surface area of the cone? Okay, we can actually do this. First thing we want to do is we want to relate something. And I'm going to do small to large. Okay, so I'm going to do 5 to 15, the radius. We can reduce that to 1/3. So the scale factor would be 1/3. We want to correspond the surface areas with one another. So again, I'm going to continue to do small to large. So 245 over, I don't know for the surface area, but then I need the scale factor for the surface area. I can't use 1/3. That wouldn't be appropriate, so I actually have to square these. That would be the appropriate thing to do. So I should get 245 over x equals 1 over 9. And now we can go ahead and cross multiply, and if I do that, it basically just becomes x equals, and I have my calculator off to the side here, 2,205. Okay, and that would be my surface area. That quick. Okay, so again, we got to go ahead and find our scale factor, and then we got to make sure if we're dealing with surface area, we'd have to square both. So I squared 1/3. Alright, given that we have solid A and B, we have the surface area, and now I want to find the volumes. Okay, well, to find the surface area ratio, we should just go ahead and put, I'm going to pick small to large again. So I got 64 over 169. Now, if you think about it, this is technically congruent to a squared over b squared. And I want to know what a and b is. So to do that, I can take the square root of both pieces. If I do that, I get 8 over 13. So this would be my scale factor. Okay, but I don't want my scale factor. I want my volume factor, because if I have the volume, I want to find what the volume is. So again, I'm going to do small to large. I know that my volume is 1200 over x. I don't know that volume. And this is going to be not 8 to 13, but since we're doing with volume, we got to cube it. Okay, so we're going to go ahead and multiply that out. That becomes 13 to the third power is going to be a decently sized number. So that's going to be 1200 times that 2197 that I just got. And then 8 to the third power is again going to be a pretty decent sized number, 512 x. So multiply the two numbers on the left to each other and make sure we're doing that right. Ooh, and that's a big number. I'm not going to end up writing that out. Divide it by 512 right away, and we should get about 5,149.2 as our new volume. Okay, and that should go right in there. I'm with going units right now for the time being, but there it is. Again, we found our surface area factor, so we had to find our normal scale factor, so I took the square root of it because that was in a squared and b squared terms, and then when we used it back with volume, I had to cube it. So very interesting problem going back and forth. Alright, here's another one. We got volume. What is the surface area ratio? So we got volume ratio. I'm going to again do small to large, so I get 40 over 85. Again, this is the equivalent of basically having a cubed to b cubed. So we got to take the cube root of these numbers, okay, which is not an easy task to do. And if you do this properly, we're just going to have to go ahead and do most of this in our calculator. So I'm going to go ahead and use the cube root on my calculator. So the cube root of 40, which is approximately 3.41, and that's going to be over the cube root of 85, which is going to be approximately 4.39. Okay. Now to get the surface area ratio, I'm going to take those numbers and I'm going to go ahead and square them. Now without taking it out of my calculator, I'm just going to go ahead and square it so I get the most precise answer. So the bottom number, 4.39 squared, is approximately 19.3. And then that 3.41 squared, again, it's completely in my calculator. I didn't actually round it. I would get 11.69. We'll just round that to the nearest tenth, so we'll get 6.7. Okay, is that super neat? No, it's not, but we can deal with it, and it works. Alright, this last problem is kind of an old throwback surface area question, where we got to find the surface area of these two figures. Okay, so we have a cone and we got a cylinder. So let's deal with the cone and let's deal with the cylinder. And I'm going to do this in a strategic fashion. The cone, I only want the lateral area. I don't actually need to find the area at the base. Okay, the surface area of the cylinder, I have to find the whole thing. Okay, so when we're doing this, I don't know if you know what that sound meant, but there it is. We get 2 pi RH plus 2 pi r squared. Okay, so we're going to go ahead and we get the radius of 5. So this is going to be 2 pi 5 times the height, which is 3, plus 2 pi 5 squared. That's going to become 30 pi plus 50 pi, and for a total surface area of 80 pi. Alright, so that's my cylinder. I'm going to circle that so I don't forget it. Now my cone. My cone is going to be 1/2. I'm sorry, we don't have to do the 1/2 because the 2 was there before. Sorry about that. We just do pi RL. Okay, and let's go ahead and find that. The reason why I'm not doing the base circle, because the base circle, this circle right here, is technically getting overlapped, so I'm not going to count it. I'm actually going to have to find the circle and subtract it at the very end. So pi RL, well, if this is 2, this is 2 over here, so that takes 4 away from 8, which I'm left with 6, which means my radius is 3, and my slant height is already given to me as 4. So I get my lateral height is 12 pi. So I got to add these two together. So I get 12 pi plus 80 pi, but I have to subtract that circle. So I got the cone plus the cylinder, the lateral of the cone, the surface area of the cylinder, but I have to subtract the area of the circle. By the way, that's how you write a circle, believe it or not. And the area of a circle is just pi r squared, which in this situation would be pi 3 squared, or 9 pi. And that's what I'm going to subtract from here, 9 pi. Once we do all of that together, we should come up with 83 pi, which is our final answer. Okay, so quite a doozy. You're going to have a problem like that on the tests. Be prepared. Alright guys, we'll see you.